Okay, here is the recording of my online class with my student. So they will be asking me some question. I will repeat them so that you can understand the question in order to understand let's say that to be to follow more easily the video. Nice. So guys, today we are going to concentrate our attention on this MCQ. It is the first MCQ for the preparation. Okay, there are many reasons for which I think that we should do this, because we have basically 12 MCQs to solve in order to prepare the exam. For these 12 MCQs were like designed to prepare the analysis one exam of the Polytechnic of Torino. But for me, by my point of view, I think that by solving all these 12 MCQs, the student is enough prepared for the exam. So this is the first one. Okay, in this first one, as you said, the stuff are related to numerical sets. Okay, but in talking about numerical set, is there any question? Okay, we're talking about numerical sets. We will learn how to solve inequalities, equations, and so on. Okay, so first question: the set of solution of this inequality. It is an inequality because we have smaller or equal, right? It's not an equation, but it's an equality. An inequality is, so they want the set of solution of this inequality. Let's try to report the inequality. So the inequality is x times log of x plus 2 over x minus 3. So we have, let me put the we have x times log of x plus 2 divided by x plus 3, that we want it to be smaller or equal to 0, right? Now guys, so when you have an inequality, the first thing to do is to bring all the stuff to one side and only keep 0 to the other side. Is that clear? I repeat, anytime you have an inequality, the first thing to do is to bring all the stuff to one side and then keep only 0 to the other side. Why why this? This because when you bring all the stuff to one side, you understand, for example, that what do I want to do? I want to find the value of x for which this stuff is negative. When something is smaller than 0, it means it's negative, yes or not? So then let me cancel what I put here. Okay, so then we want to find for which value of x this stuff is negative because it's smaller or equal than 0. Is that clear? Nice. Now, how many components do you see in these inequalities? When I mean components, it means we have this component, right? This one, and finally this one. So the equality is made by 3 components. The question that you should ask yourself is the following: if I know the sign of all these 3 components, am I able to recover the sign of all the fraction? If, for example, this x is positive and the logarithm is negative and the denominator is negative, what will be the total sign of this function, of this fraction? Plus, yes, in fact it will be positive, right? So this means that if I know the sign of every component, I can recover the sign of all the fraction. Yes or not? When the fraction is like this, we say that the fraction is already factorized. Factorize it. Okay? So first step, bring all the stuff to one side. Second step, check if it is factorized, yes or not. Okay? In this case, it is already factorized in the sense that if I know the sign of each component, I can derive the sign of the fraction. Yes or not? But if you have something, for example, like x plus exponential of x divided by x minus 1, if you know the sign of x and the sign of exponential of x, can you derive the sign of the sum? When I do minus and then I do plus, for example, When I do something which is positive plus something which is negative, do you know if it is going to be positive or negative? No, it may, yes or not. So this, in fact, it depends on the values. Is that clear? So this stuff here is not in the factorized form, but this one is already in the factorized form, right? So now we can, for example, for x, so we will study the sign of each component. We say x greater than 0. When we know this component, we don't need to study the sign, because this x is greater than 0 only when x is greater than 0, yes or not? Then the second component, it's logarithm of x plus 2. We want, for example, this to be greater than 0. Why am I choosing? It's not important to choose greater than 0 or smaller than 0. You will understand why. Okay? So now to do this, how do I solve this? To eliminate the logarithm, what do? I apply the exponential to both the sides. Okay? So I write exponential of, so I write here, I apply the exponential to both the side. This will be, if the exponent, it will be exponential of the logarithm of x plus 2, and here will be exponential of 0, right? Then what is exponential of log plus of a quantity? When you do exponential of the logarithm of any quantity, you get the same quantity. So this will be exactly x plus 2, right? That should be greater than exponential of 0, which is 1. Okay? So we get that x should be greater than minus 1. Yes or not? So what do we get? What do we got? We got that this stuff here is positive when x is greater than minus 1. Is that clear? Let me put the full board. We got that, excuse me. We got that this stuff here is positive when x is greater than minus 1. Is that clear? Now let's take the last component. The last component is x plus 3. So we go x plus 3 greater than 0. It's when x is greater than minus 3. This is easy, right? Now please guys, open try to hear me the maximum you can, because here I am going to do something very important. This table that I am going to do now should be your best friend, because it will help you a lot, also for the study of function. So now what is this? When I do this table here, I put x, right? Then look, what is the domain? When I say the domain of this inequality, what do I mean by the domain of this? You know that, is it possible to do the logarithm of minus 1? No, we cannot do the logarithm of negative number, right? So the condition for the condition for this inequality is that x plus 2 should be greater than 0, right? The equation was x plus 2, right? It was exactly like this, right? I hope we didn't make any mistake. So the equation makes sense only when x is greater than. So the domain for this equation will be from minus 2 till plus infinity. Then you have to sign up all the points that we saw. Which point we discovered that we need the point minus 1 and the point minus 3. Yes or not? Let me go back and check if I am right, because maybe okay, it was this was x minus 3 and I wrote x plus 3. It was x minus here. See the denominator. Here is x minus 3. Okay, so here it is x greater than 3. Doubts? So in this table now you will have, so which are the points that we discover? We found the point minus 1, this one, and we also found the point 3. So we put them in order. We have minus 2, then we have minus 1, and then we have 3, right? Okay, first, what if we now put all the components? The first component was x. Okay, and then we also found 0. the point 0, because we saw that the first component changed the sign at 0, right? This for x greater, yes or not? So we found 0. Why do I put 0 in here? Yes or not? Let me do some space between. Let me put some space between the stuff. So it is, we said that we have to put -1, 0, and 3. Okay? Then the x then we put the line of x. The line of look x. Then we first of all you need to here you split here, and you split also. So at any value you split. Is that clear? Now we put x. Then we put logarithm of, it was log of what? X plus 2. Then the last component was, okay, it was x minus 3. And then finally we write here all the function. Let's call it all the inequality. That is excuse me, all the inequality should be actually x minus 3, x multiplied by the logarithm of x x plus 2 divided by x minus 3. This is all the inequality. Okay, now we are ready to write down all the steps. This x vanishes at 0, yes or not? Okay. The logarithm of x plus 2 vanishes at -1. We saw it here. X minus 3 vanishes at 3. Nice. We saw that this x, where now you understand why I was solving to be positive. X is positive only when x is greater than 0, right? So here we'll put negative, negative, then from 0 we'll put positive. Is that clear? Nice. Then for this guy, you see that this guy, the logarithm is positive. The logarithm is positive when x is greater than -1. So here it will be negative, then positive, positive, positive. Right? Now we have x minus 3. We saw that x minus 3, this was minus, excuse me. X minus 3 is positive when x is greater than 3. So this is minus, 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 and then for it is positive. Now you just do minus times minus, plus divided by minus, minus. Minus times plus, minus divided by minus, plus, 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 minus, minus, and plus. We turn back now to the inequality. We wanted to get in which interval this inequality was negative. Okay, so we saw that our solution, it is from open to minus infinity till -1. Then why did I open to minus infinity? Because the infinity is always open, right? Then I don't know from -1 yet, so let me just keep it for the moment. Union, then I have to take also the interval from 0 to 3, right? Because it's also negative. Yes or not? Now let me try to understand why should I should close at 1 or I should skip it. Let's go. You just put 1. I am asking, should I close at -1 or I should open? Okay, you take -1 and you bring it inside the inequality. If we put -1 in the inequality, we'll get -1 times the logarithm of -1 plus 2 divided by -1 minus 3, right? That will give me -1 multiplied by the logarithm of 1 divided by -4, but the log of 1 is 0, right? So it gives you 0. It gives you 0 smaller or equal than 0. Is true or false? This true. So we take -1, right? And we close. The same we do for 0. You see, if you put 0 at the place of x, you will get 0 smaller or equal than 0. So we also take 0. Yes or not? But if you put 3, we'll get something divided by 0, which is impossible. Yes or not? So we skip for 3. We cannot divide, but we open at 3. So here is the solution. And yes, it's a number. The question of my student is that let's put that we should do the step at 0. So logarithm will be 0 multiplied by log of 2 divided by minus 3. Yes or not? So we get 0 smaller or equal than 0, that whole. Okay, so let's go back to see if we had this possibility in our MCQ. And in fact, no, excuse me, it wasn't from minus infinity. The table moved from minus 2, right? Not from minus infinity. Excuse me for this. This is from minus 2. So the answer is B, right? Is that clear for all of you? Okay, the answer is 1B. Doubts? No, because the table started at 2, at minus 2. The interval is from minus 1 to, from minus 2 to minus 1. It's not minus infinity because we saw that the inequality makes sense. Okay, I repeat. The question of my student is why why the interval here. Yes, in fact, the question of my student was why we didn't start here from minus infinity, because of the logarithm. Okay, the condition of the. Okay, any question for this exercise? Okay, let's move to exercise 2. Okay, the set of solutions of the inequality sine 5x plus cosine 5x smaller or equal than 2 is. So you are given the inequality, which is the sine of 5x plus the cosine of 5x smaller or equal than 2. Okay, guys, please, before starting, I know I told you that any inequality you have, you should bring all to one side and then study the sign. Yes or not? But is it possible to? It's very difficult to deal with sine of 5x and cosine. Yes or not? So when the inequality is so that difficult, the first technique that we saw, you cannot apply it. It's not applicable. Okay. So what you can do is using your mind. Using your mind, what does it mean? Tell me something, guys. From the high school, you should know that the cosine of any angle, whatever is the angle, is between what and what? Minus 1. In fact, the cosine of any angle never go out of this. The same for the sine of any angle. Whatever is the angle you take, this always holds. Then suppose that if I sum up the cosine of any angle, quantity, this QT stands for quantity of any quantity, plus the sine of any quantity. In the worst case, what will I get? If I do this plus this. In the worst case, I get minus 2. And in the best case, I get. What did I prove? I proved that whatever is the quantity, the cosine of any quantity plus the sine of the same quantity will never exceed. Okay? This means that this whole whatever is the quantity, it whole whatever is the quantity you take. So coming back to this equation, whatever is the value of x I take, this stuff will always hold. Is that clear? Whatever x I take, whatever x belonging to R I take, if I do the sine of an angle plus the cosine of that angle, the result will always be smaller than 2. So this is what we call an evidence, something which is evident. Okay? This is, it holds for every x. Whatever x I take, the cosine of any quantity plus the sine of that quantity will always be smaller than 2. So we say that it holds for every x in R, and the solution is. A typical it's like if I ask you to solve the equation x squared plus, for example, x squared plus 1 greater or equal to 0. You know that this stuff will always be greater or equal than 0, because you take a positive quantity plus 1, for sure it will be always greater than 0. So also the solution here will be R. Or maybe I ask you to solve x squared plus exponential of x greater than 0. You know that exponential of any quantity is always positive, right? And x squared is positive. So the sum of two stuff which are positive will always be greater than 0. So also the solution here will be R. Okay? Okay. So the answer here is 2B. Any question? The tangent of the quantity, no, but pay attention that the tangent of x assume value between minus infinity to plus infinity, because the graph of the tangent, when you draw it, it's something like this, okay? You see that the possible value move from minus infinity to plus infinity. So that for the tangent, this kind of stuff doesn't work. Okay, now so this is the end of the first of this recording. We'll continue solving the MCQ in our next recording. Thank you.